Hello, this is David. Welcome to an updated video review from Michael Miller's Mathematics and Statistics for Financial Risk Management. We are in Topic 2, Quantitative Analysis, and this is Chapter 2. It's called Probabilities, and it's the first chapter in a sequence that introduces the core statistics portion of the FRM Part 1. So this is a very important sequence of concepts in the FRM syllabus. Matthew Miller has now been assigned, this is the assigned author, for this portion of statistics for several years in the FRM syllabus. So it is seasoned, and it is also contains several highly testable concepts, I would say, on the one hand, and also, just as importantly, on the other hand, many of these concepts show up later, or they are embedded in concepts that are later applied in the financial context, right? So they have importance on their own in terms of statistics and econometrics, but also they are applied, some of these are applied later when we get to specific asset classes or specific instruments or specific risk buckets. So it's a double whammy in terms of their importance that way. Here are the learning objectives. Most of these are quite seasoned. Some have been in the syllabus for up to a decade. So we have some very fundamental probability concepts here. You can see including we want to be able to distinguish between a continuous and a discrete random variable. We also have define and distinguish between the probability density function. So that, for example, is something that I typically don't even say that out anymore. I would say PDF. And then a cumulative distribution function, then that's something that I would write with capital letters. We'll see why, as a CDF. Cumulative distribution function. We have the inverse cumulative distribution function. If you see this, if you're seeing this for the first time, that's going to be an intimidating phrase probably. Well, we're going to look at that, and that's also called the quantile function. Very important for us. And notice we do have a calculate verb in there. We have the calculate the probability of an event given a discrete probability function. As I've mentioned many times, we want to pay attention to the language, the particular semantics of the syllabus for a couple of reasons. First, because it's been refined over the years. GARP's accepted feedback, acted on feedback, and these verbs, what I call the action verbs, are, in particular, they're very deliberate and intentional at this point, right? The difference between a describe, a define, and a calculate action verb that implies a higher level of skill. That implies we need to be able to have the skill to actually perform the calculation. Where we have distinguished between an independent event. Independence is such an important concept in the FRM syllabus. In many cases, we're making an assumption about it. We're assuming independence, sometimes implicitly. Then we have a really important concept sentence here with that goes to the fact that not all probabilities are the same. Sometimes the word probability is not specific enough. So we want to just review the difference between a joint probability and some other probabilities here, like a conditional and an unconditional. So if you happen to be taking notes, you don't need to because the slides are downloadable, but definitely keep in mind that it's really important that we distinguish between joint probability, conditional probability, and unconditional probability. These very foundational and made a little bit tricky because sometimes some authors use different terms as synonyms. So, for example, unconditional tends to have the synonym of marginal, tends to mean the same thing. Okay, but we'll look at that. Before we get to the learning objectives, we like to, in the study notes and also here, introduce some key terms because in probability, well, like the rest of finance, but especially in statistics, the specific meaning of terms is really important. And you see this as you study. You see these when you look at practice questions. Some authors are a little more sloppy than others are more precise. Well, in probability, it's important to be precise. So we introduced here some selected key terms, and we'll see that for example, the population is an important term. Statistics, in many cases, about taking a sample and inferring from the sample some properties or parameters of the population that we can't observe. We have here a distinction between outcome and events. So, for example, if we're rolling two dice and playing craps, rolling a 4 and a 3, which equals 7, of course, we could call that an outcome. But we can also get that by rolling, let's see, we could roll I'm not going to draw very good dice, but here we could roll a 1 and a 6, could we not? And now that would be a different outcome than a 3 and a 4, but it would be the same event of rolling a 7. So see that distinction.